Well, thank you for inviting me, and I'd like to add my voice of congratulations to Martin to semi-retiring and ditching some of his academic responsibilities and focusing on science. I think that's very important. I have been privileged to be in the room when the KCs were born with much struggle, as Vince already pointed out, but I think it was for good cause. And while cancer hazard is certainly a driver for a lot of regulatory decision making, non-cancer endpoints are also very important. And as many of you in the room know that when you prepare your assessments, you really need to look at everything, and everything typically means something. It's not everything. There's a list of ISITs, and one has to go through all of those, and one has to find all the evidence on them, and one has to evaluate that evidence. So it was quickly realized with encouragement from Lauren Zeiss and her colleagues, and also folks at US EPA who are doing things comprehensively rather than just cancer hazard, that we really need to cover other ISITs. And I was privileged to lead a group that I'd like to acknowledge here as co-authors of the paper that we published in a clinical journal. So hepatology is one of the top 6 journals in the clinical field concerning liver. And we really wanted to make sure that we are spreading the word about characteristics of drugs or chemicals that can actually injure a particular organ rather than just be cancer causing in any type of cell and tissue. And by putting this into a clinical journal, we really are trying to reach out to clinicians, to practitioners beyond just toxicologists or regulators. And as you see, the title is very inconspicuous. It talks about key characteristics, but now it talks about a particular organ or tissue, and we'll hear a couple of examples from my colleagues on other organs and tissues. And while the challenge is, where do you stop? 45 tissues are being evaluated in a 90-day study or 2-year cancer bioassay. Do we need 45 sets? Probably not, and that's some of the discussion that we will have later today. But again, with great acknowledgement to Martin for encouraging me to put this group together, and for a wonderful group of collaborators representing different sectors, from mechanistic toxicologists to regulators to folks in the drug development to clinicians, who really, I think, had a lot of fun doing this on Zoom. So I only have a couple of slides, and we will have a chance to see these key characteristics. The reason I put this up was to point out that some of them are recurrent themes, right? So we all understand that things are injurious in fairly similar ways. But once you start talking about organ-specific effects, you really need to start thinking about what is happening in that particular tissue and may not happen in other tissues. So in this particular list, which was 12, and again, it's always a challenge of first, expanding your horizons in your mind to a large number, and then trying to synthesize things down to a manageable list. I think it wasn't as difficult as some of our group members have thought originally as to how we can actually make this infinite universe of ways in which chemicals and drugs can injure liver into a very finite number of things. And when, again, you look at this, you will see that I could not marvel by saying, why did we put KC5, oxidative stress? I think it should be permanently with caution type of a key characteristic, but it wasn't by design, but I just recognized that it is actually key characteristic number 5. But a more difficult challenge with organ-specific ones is that you have to think about things that are probably much harder to evaluate using in vitro methods or to model using in silico methods. For example, cholestasis or liver fibrosis. So here in this list, we're going from very understandable, very queryable with in vitro methods things, to fibrosis, which is very, very difficult to model in vitro. Not impossible, but very difficult. So as we have a discussion about potential methods as to how we can measure these or evaluate these key characteristics, we really need to think about that as well. Now, at least, in our manuscript and in our work, we wanted to put some examples of how these key characteristics relate together, kind of similar to that benzene example. And while the benzene example had some lines crossing and was by design complicated to show that it is actually complicated, we wanted to have a little bit of more linearity, but also recognize that some things happen perhaps together and some things can be impacting each other. And some things are actually almost a terminal key characteristic or event that actually leads to the pathology that will be recognized. So two examples here on the screen are chemicals. So, TCDD and vinyl chloride. And we picked those because really they are, we didn't want to have everything looking the same. It's just electrophile. It can, cause oxidative stress, and then there's mitochondrial damage, and then there's cell death, and then you have some compensatory cell proliferation. So I think these two examples were chosen based on the fact that they really represent very different ways in which you can arrive at liver injury. And while both of them have fibrosis at the bottom, and that's why it's one of the key characteristics that our working group members were adamant about including, really there are multiple ways to get there, and I think that's very important for us to recognize. Then obviously a lot of drugs happen to have liver as their target, or intended or unintended. And here are two examples: amoxicillin clavulanate, antibiotic combination versus acetaminophen. And I knew that Martin is a Renaissance man, but I did not know that he was once upon a time, a liver person as well. So I keep learning, just like Kamal showed the HZs, nature stork story. It actually used to work for Helmut Z's, and I was wondering if it's the same HZs. And what Kamal showed on the screen is actually the entire communication in nature. It's actually one sentence and one image. It was in the communications section. So it's interesting how some of the greats in science, they really are multidimensional. But again, here, this is really, while both of these go through metabolic activation, they're really not working through the same downstream key characteristics. And I think it's very important to recognize. And then finally, biological agents are also injuring liver and other tissues, and they also are under evaluation. And here in this particular case, we're showing that hepatitis virus B and C, and again, some of you in this room were, went through studies of these. Again, how can we linearize some of the complexity? For example, the interaction between inflammation, oxidative stress versus the signaling pathways and death of liver cells. So I want to leave you with some examples, and I'm interested to hearing from my colleagues about other ones, and then hopefully again we'll discuss how this can be used by regulators beyond cancer hazard evaluation, which I think we're all very comfortable with right now. So thank you.